Assalamualaikum. Today we're gonna study what happens after the formation of a zygote. Okay, so after a zygote is formed, it performs mitosis and first reaches this two cell stage. These two cells then further divide to form four cells. Notice that these cells are smaller in size as compared to these two cells, but they are more in numbers. So this kind of division is called cleavage division. Okay, these cells continue to divide and eventually they reach a stage of 16 cells after 3 days of fertilization. This stage is called morula. Note that the inner cell mass of there is inner cell mass of morula and there is outer cell mass of morula, and this zona pellucida is still present in morula. All right. When the morula enters the uterine tube, a fluid starts penetrating through the zona pellucida and starts accumulating in the intercellular spaces. Keep in mind that in compaction, we studied that these cells are attached to each other through tight junctions and communicate with and inner cells communicate with the outer cells through gap junctions. But here in morula, when it enters the uterine tube, a fluid starts penetrating through zona pellucida and starts accumulating in the intercellular spaces. All right. Now at this stage, these cells are this like this. You cannot see that the fluid has accumulated in intercellular spaces, and the trophoblast cells, which were made of the outer cell mass. Alright, I forgot to mention that before. The inner cell mass of morula will form embryo in future, while the outer mass cells of the morula forms placenta in the future. All right, is that clear? So the embryoblast cells of in the blastocyst stage, they become flattened and form the epithelium of blastocyst, while the embryoblast cells gather at a pole. Okay, so uh, since the fluid has penetrated through the walls of through zona pellucida, so zona pellucida has disappeared at this stage. Okay, and all this has happened until the sixth day of after the fertilization. Okay, now we have studied how blastocyst is formed, but now we might think how does it get implanted into the uterine tube? It has entered the uterine tube, has become a blastocyst from morula, but how does it get implanted into the uterine wall? So uh, there is L-selectin on the trophoblast cells, which acts as a ligand for carbohydrate receptors, specific carbohydrate receptors on the membrane of uterine walls. Uterine walls recognize it as receptor and capture it. All right. After it is captured, it has to attach to the walls of uterus, and it has to invade those cells so that it get implanted into the uterus. Okay, and this is done by cooperation between the endometrium and trophoblast itself. Note that embryoblast has no role here, no role in implantation. Intergene is present on the trophoblast, and laminin and fibronectin. These are extracellular matrix molecules which assist the blastocyst in its implantation into the wall of uterus. Okay. Um, Laminin laminin receptors on intergene promotes its attachment to the uterus wall, while fibronectin stimulates the migration deeper into the endometrium. Okay, are we clear? And all this has happened during the first week after the fertilization. Okay, after the first week of fertilization, the embryo, the zygote, has already reached the morula stage, the blastocyst stage, and it has even implanted itself into the wall of uterus. Now we'll see what happens after the seventh day. On the eighth day, the trophoblast over the embryoblast starts dividing itself into, not dividing, I have used the wrong word, you have to use the word differentiation. There is a huge difference between differentiation and division. You have to use the word differentiation here. All right, I'll even highlight it. It differentiates into two layers. The outer layer, uh, which is, no, I'll first mention the inner layer because it is mononucleated and cells have distinguished boundaries and they are called cytotrophoblasts. And the outer layer, and in the outer layer the cells have no distinct boundaries. They are fused together and they are called cytotrophoblasts. All right. uh, you must have noticed that some people get influenced by other people very fast, and they, in an attempt to be like those people, they lose their individuality and become just like them. The same happens here. The cytotrophoblast cells divide and migrate to cytotrophoblast and lose their individual cell membrane and fuse with those cells. All right, and we have talked about what happens to trophoblast here. Now let's discuss what happens to uh, embryoblasts. Embryoblasts also get differentiated into two layers: the epiblast and the hypoblast. Hypoblast is ventral or interior layer, while epiblast is dorsal or posterior layer. Okay, the hypoblast is adjacent to blastocyst cavity, while epiblast is adjacent to amniotic cavity. You have to remember these differences. Alright, they are important viva questions. They are important. They can be important SCQs if they ask you SCQs in the paper, and they can be important MCQ points. So you have to remember which is adjacent to which. Okay, next, you have to also remember one more thing, that hypoblast cells are cuboidal, while epiblast cells are high columnar. These epiblast, the cavity starts forming between these high columnar cells, which forms amniotic cavity in future, and the cells lining the amniotic cavity, they are called amnioblasts since they line it. Okay, a question arises in our mind: if epiblast is forming the lining of a cavity, then hypoblast should also do something similar, no? It does. It actually does, but it happens on the day 9. Okay, now hang on tight. We'll go on day 9, but first let us complete the day 8. Okay, we are almost finished. We are almost finished. Just you have to remember one more thing, that the endometrial wall is vascular, highly vascularized at this point, and the glands secrete glycogen and mucus. On the day 9, uh, I forgot to mention one thing before. On day 8, the implantation of blastocyst in the uterine wall was partial, but on the day 9, it is fully, deeply embedded into the uterine wall. So this is the first thing that happens on the day 9. The second thing that happens on the day 9 is um, blockage of penetration defect by fibrin clot. Remember when the blastocyst got implanted into the uterine wall, there must have been formed a hole in the uterine wall, right? So that hole is filled by a fibrin clot. That is the second thing that happens on the day 9th. The third thing is the trophoblast shows progress, and vacuoles appear in them. These vacuoles fuse together to form leucine, and this stage is called leucinar stage. Leucine literally means lakes. Now, uh, recall that vacuoles are storage bodies, right? So it becomes like I don't know what it is called exactly, but I'm calling it lacune. All right, I don't know its pronunciation actually. So lacune becomes a part of placenta in future, and it is filled with blood. So these are storage bodies. Okay, now let's move on to the next part. We have studied three things happening here: the complete implantation of blastocyst. Second, the blockage of penetration effect. Third, the formation of the lacunar stage. And third thing that happens is the formation of primitive yolk sac. I mentioned before during when I was telling you about the amniotic cavity that there is cavity formed in the epiblast, in between the epiblast cell, which is amniotic cavity, and these cells line the amniotic cavity, and the cells are called amnioblasts. So here hypoblast cells form flattened cells which form goes on to line the inner surface of cytotrophoblast. Now, a question might arise in your mind that if the hypoblast cells have are forming are lining the blastocyst cavity, then why is cytotrophoblast mentioned here? So here, take a look at this diagram. This is the blastocyst cavity. This is the amniotic cavity. You can see epiblast cells are lining it. Now this is the blastocyst cavity, and here take a look. These are cytotrophoblasts that surround this cavity. So these hypoblast cells, flattened hypoblast cells, originate from the hypoblast, which is somewhere here. So these form a layer, a lining, which is exocoelomic membrane, and this membrane together with hypoblast forms the lining of exocoelomic cavity or primitive yolk sac. Alright, are we clear?